So in this math, we need to prove for part A, we need to prove cos square theta equals to this one. And then for part B, we have f of theta equals to this equation, and you need to simplify this whole thing to get this line. For part C, we need to solve maths for different quadrants. For part D, we need to integrate. So let's start with part A. So since it has to be derived from cos 2 theta, double angle formula of cos, I will just replace A and B with theta, so that we get theta plus theta equals to theta. So this is part A, and so this is the formula of cos A plus B. So in this one, you just need to replace A and B. You use theta, and then you get cos 2 theta at the left side. You have cos square theta minus sin square theta. So sin square theta can be replaced by 1 minus cos square theta from the formula sin square theta cos square theta equals to 1. From here, if you just subject sine, you will get 1 minus cos. And why do we need to do that? Because we need to have cos square theta equals to something. So we do not need any sine, any terms for which related to sine. So you need to replace sine. So from here you get minus 1, minus minus will give you plus. So if you just add the terms related to cos theta will give you 2 cos square theta. So basically we need to subject this one, right? We need to subject this one. So we need this thing at the left side of the equation. So if I just shift this whole thing at the left side and this at the right side, we get this line. So from here, if you just subject this one, 2 cos square theta, you need to shift this at the right side. So it will be cos 2 theta plus 1. So at first I just switched this position of this to right side and left side, and then I just subject it to cos square theta. And at the very last line, you just need to shift this 2 at the right side, so it will be half of something. So that's part A. So for part B, we have this equation, but we can replace this one with the answer from part A, right? Because we need 2 theta, so we have 2 theta here, so we can replace this one. What about this? Cos to the power 4. Since we know values for cos square, we have to somehow convert this into a format so that we can just substitute values, right? So if we just use 2 square whole bracket 2 square, it's the same thing, 2 to the 4, right? But if we just write this thing in this format, then we can just replace cos square theta in this 2 position by this, right? So that's what I'm going to do. For part B, this is the given equation, and that's the final line that we will get. So let me start with the very first line, and like I said, we can convert this thing into cos square whole bracket square. So 2 to the 4 is the same thing but in different format. That's it. So I'm just using a bracket sign here, a bracket here and a bracket here. So you just replace this 2 cos square theta inside the bracket by this one, half of cos 2 theta plus 1. So cos square theta is half of this, and we have a whole square, so that's why I'm just using a third bracket, and this whole square is outside this bracket, and 4 into this, so 4 into this whole thing, this part. And then since this square is will be given to both of this, 1 by 4, 1 by 2 square will give you 1 by 4, and this part cos 2 theta plus 1 cos 2 theta plus 1 also has a square, right? So and at this part you can just cancel it out to get 2, and now we can just start multiplying. So if we multiply this thing, you get 2, but we still have a square sign here, right? So we need to expand that using a plus b whole square formula, and this one you just multiply that. So if we expand this one, it's a square 2 into a into b. B itself is into 1, so you can ignore 1 here. So the line will be a square, so cos 2 theta whole square, so that's cos square 2 theta. So a square 2ab, so 2 into cos theta into 1, so that's 2 cos theta plus b square, which is 1 square. So 1 square will give you 1. So this is the expanded version of this. I just used the formula for a plus b whole square. And this minus 2 will give you minus 3. 2 cos theta is still there. And now I will just start multiplying. 2 into something, 2 2s are 4. 2 into 1 gives you 2. And after this line, this is unchanged, but 4 cos 2 theta minus cos 2 theta. It's the same thing, cos 2 theta, cos 2 theta. 4 minus 2 will give you plus 2. And minus 2, we have minus 2 and minus 3, so that will give us minus 1. Minus 1, and then the problem is that we have simplified this part, but the thing is we need to prove cos 4 theta cos 2 theta, as in we already have this term 2 cos 2 theta, 2 cos 2 theta, but we need to replace that. We need to replace that one. So as you can see, we have a square, but in the final line we shouldn't have any square, right? And it's 4 theta, but it's 2 theta, so we need to change that angle. So if you just look at this formula, cos square theta is this one. So if you actually use a here, this part will be 2a. Like you can replace values of theta whichever situation demands. Like if you replace theta with a, this part will be 2a, right? Similarly, if you replace theta as b, since theta is b, 2 theta will be 2b, right? In that same way, if you replace theta with 2 theta, if you just use theta with 2 theta, this one will be 4 theta, right? Because 2 2s are 4. The easier way to remember this is that at the left side we have single angle, which is theta. At the right side we have double angle. So whatever you write here, at the right side you are going to get the double angle, right? So if it's 3 theta, you should get 6 theta at the right side. If it's 5 theta, you should get 10 theta. It's just the double angle, that's it. Okay, so that's the concept we are going to use. So the formula, if I just write 2 theta here, that's what I have here, right? Cos square 2 theta. At the right side, each and every single term should be same. 2, 1, everything should be same. It's just the difference in the angle. The angle should be 4 theta. Okay, so this is the term I have just replaced here. So 2 is here, cos square 2 theta is this. Okay, so if you just cancel this, you have cos 4 theta plus 1. So this one, when you cancel out, this is the last line. So this is one of the way. And then again, if you actually remember this formula, like this version of this formula, like 2 cos square theta equals to cos 2 theta plus 1. If you just rearrange this thing, so 2 cos square theta minus 1 should be cos 2 theta. So you can even replace 2 cos square something. Okay, wait, it's the same thing. You need to understand that if you replace 2 theta here, you are going to get 4 theta. Like even if you take 2 cos square something, okay, you can subject here and then replace the values. I didn't bother taking 2 cos something. I just used this version, the subjected version of cos 2 theta. I replaced cos 2 theta here. Okay, so that's the last line for part B. For part C, we have this equation equals, it's supposed to be 1.5 here. Okay, so as you can see, we have 8 cos to the power 4 minus cos square minus 1. 8 cos to the power 4 minus cos square, but we do not have any minus 1 or something. But the first 2 term is common, right? It's the same thing. So basically I need to replace this whole thing. So from this equation I can replace the first two terms, which is here, right? So in this equation, we do not need this minus 1 for the time being because we do not have the minus 1 here. So we just need to replace this two terms, 8 something, 4 something, right? So from this equation, if I write 8 something cos something, 4 something, 8 cos to the power 4, 4 cos, this minus 1 should be shifted at the right side, right? So it will be plus 1. So that's what I'm going to do here. If you shift this minus 1, it's gonna be like this, plus 1, right? So at the left side, you basically have f of theta plus 1, right? This minus 1 should be shifted here. In that case, you have f of theta plus 1. In short, from this given equation, you just need to subject the part that is related to your math. So 8 cos to the power 4 minus 4 cos square theta. If I subject this, I need to shift this thing. So it's supposed to be f of theta plus 1. So I can replace this thing using f of theta plus 1. Okay, so this whole thing will be replaced by f of theta plus 1. So f of theta plus 1. So this first two terms are replaced by f of theta plus 1. And the remaining terms are still there. Okay, so we have f of theta plus 1 and f of theta. We have two equations of f of theta. This one we just replaced, right? So you use the second one, the simpler one. So it's cos 4 theta plus cos 2 theta. You replace that one. So cos 4 theta, 2 cos 2 theta is the value for f of theta. We still have plus 1 here, so it's here. And then when you remove the bracket and start simplifying, you will get cos 4 theta, 2 cos 2 theta plus 1, and this thing. As you can see, plus 2 minus 2, it's the same thing. You can cancel them out. So you're left with cos 4 theta plus 1 and 1.5 at the right side. So we need to subject cos 4 theta. So that's the final line. So the basic acute angle is 4 theta. So cos inverse of 0.5, it will give you 60, and it's positive, so all sine tan cos, so it's the first and fourth quadrant. So theta and 180 plus theta, sorry, theta and 360 minus theta. So theta is 60, 360 minus 60 is basically 60, 300, sorry. So 60 and 300, so 60 and 300. But the thing is, we had 0 to 180 as our range. This range is for theta, but the basic acute angle is actually 4 theta. So you need to multiply each and every single value with 4. So 0 into 4 is 0, 4 theta, 180 into 4 will give you 720. So this is your new range, like between 0 to 70, you need to select each and every single value. So initially we had only 60 and 300, but since we had 400, 500, 600, 700, we can go all up to 720. We have to select every values within this range. So that's why you need to rotate. For every rotation, you just need to add plus 60 with the angles. So this were my original data. So I'm just adding plus 360 with the first angle. So 60 plus 360 will give me another value. Then 300 plus 360. So these two values are from the rotation. You need to rotate whenever you have range, you have larger range, and if that values are within the range, then you need to rotate. So 60, 300, these are the original data. This is the first value, 60 plus 360, and from the second one you get another value. So these are the four values, and as you can see, all the values are within the given range, 720. I'm comparing the new range because it's the 4 theta and you are calculating values of 4 theta. So if you check this one, after subjecting theta, you need to divide all the values by 4. all these four values will also coincide with the original range 0 to 180. All the values will be within 0 to 180, so you don't even need to cross check that one. You just check with 4 theta, your basic acute angle. You check values for your basic acute angle, so all the values are within this range of 720. If the range is 1800 or something, in that case we need to rotate twice. So just like I added 360, I need to add 720 for the second rotation. But if I do that, it will cross 720, so that's why I'm not actually rotating twice. You just need to rotate once to get another two values. So these are the original data, these are from the rotation. So altogether we have four final values. So 15, 75, 105, 165, these are the four values of theta. So that's number C. Then for part D, we need to integrate f of theta. The limits are given, and this one is equals to k root 3. So it's like you need to solve this and get the result, then you can compare their given value with your one. So let me start with the left side of the equation. So the left side of the equation is this one. So f of theta, we need to just integrate f of theta. So obviously I will select the easier version of f of theta. So from these two values I will just select the second one, cos 4 theta, 2 cos 2 theta. So cos 4 theta, 2 cos 2 theta. So if you integrate sine, you will get minus cos. If you integrate cos, you get plus sine. So we have cos, so it's plus sine. Cos 4 theta will give us sine 4 theta. But we have a coefficient of 4, so that's why you need to divide this whole thing by 4. 2 cos 2 theta, so it will be 2 sine 2 theta, but then again we have a coefficient of 2, so you need to divide this whole thing by 2. And these are the limits. So if I just simplify this whole thing, it's 1 by 4 sine. If you cancel this, you have only sine 2 theta. So inside this bracket, I'm just substituting values of theta, the upper limit. So it's pi by 3 here, pi by 3 here. So sine 1 by 4, sine 4, then replace the value of theta as pi by theta. And for the second one, you need to replace theta as in the lower limit. The value of theta is 0. So sine 4 into 0 is 0. So sine 0. Sine 2 into 0 is 0. So sine 0. Then from the calculator, you will get the values. So sine 4 pi by 3 is this one. Sine 2 pi by 3 is this one. And sine 0 is 0. Sine 0 is 0. So if you simplify this whole thing, the final line is 3 by 8 root 3, but they said k root 3. So coefficient of root 3 is basically k. So k is 3 by 8. Yes, so k is 3 by 8. So this is part C and D. And that's A and B. So that's the complete solution of this math.